So in this mini lecture, we're going to look at evaluating functions given their graphs. And in this case, we have the function f, which is colored in blue, and g, which is in green. So our first portion says, let's go ahead and find f of 0. So to find f of 0, of course, we're going to be using the function that is colored in blue. So the 0 is our x value. So we look at our x value at 0 is right there at the origin, and then we'll go up to the function, and now we'll say, okay, what's the y value right there? At 0, the y value looks to be, if this is a 2 and that's 4, they're counting by 1, so this is 3. So f of 0 equals 3. All right, now we'll do the next one. The next one says g of -2. So we're going to use the green function, the one that's drawn in green. So we'll go to -2 where x is -2, right? X is -2. So at -2 is right over here, and then I'll go up to the actual graph of the function, which is right there, the green. And then I say to myself, looking over, the y value is 1. So at g of -2 function, our y value is 1. All right, and then we'll go over and say on what interval is f of x less than or equal to f of x less than or equal to g of x. So we're trying to find out where our function f is less than g of x. Well, that's just coming from looking at the graph. And we're going to say, okay, f of x is in blue, g of x is in green. So right here, from here to here, this is below the green. That blue is below the green. So we're saying what interval. So when we say what interval, the intervals are the x values. So x value is from here, which is -4, right? From -4 to here, -2, right? And that's where the function f is below. When it goes past -2 up here, this is above. All that is above, so it's greater than. So then again, it's below right here, right? I see it below. The blue is below the green right here, and is actually to here. It may look like the graph goes on to 4, which it does. However, the green graph, the green function g, doesn't go to 4, so you can't compare them if it doesn't go that far. So we see that it's below right here from 2 to 3. So from 2 to 3. Right, so that's where, and I'm sorry, I should make this closed interval. All right, and that's where the intervals are where f of x is less than or equal to g of x. In this portion, we're looking at evaluating functions. So the function given is f of x is equal to 2x squared minus x plus 3. Here we're told to evaluate, we'll do f of 3. So all we do here is just substitute in everywhere we have an x, that 3, because that's saying x is 3. So I'll make my parentheses to show substitution, then I'll substitute the 3 in. So 3 goes there, 3 goes there. Of course, you have to do correct order of operations. So 3 squared is 9. times 2 minus 3 plus 3. We get 18 minus 3 plus 3. And then we get 15 plus 3. And then lastly, we'll just say that f of 3 is equal to 18. 18 is our y. Sometimes they may ask, it depends if you're using some type of computer algebra system, to input it as an ordered pair. An ordered pair is written in with parentheses with a comma between the two values, the x value and the y value. So we'll have 3 and 18. Sometimes we may have something that says, okay, let's find f of a. So they'll just throw a variable in there. And remember, again, f of x is 2x squared minus x plus 3. So all they're saying is just plug in an a where you see an x, just like we did above when we plugged in a 3. We're going to plug in an a everywhere we see an x. And we'll just say a to the second minus a plus 3. And then just go ahead and write it as such, 2a squared minus a plus 3. And that's all you can do there. And this will be our answer for that. The next one I want to do is we're using the same function, 2x squared 2x squared minus x plus 3. So same function. I'm just going to refer to this function every time. So if you have that written down on the side, that's good. So I won't have to rewrite it. So all we do is substitute a plus 1. So f of a plus 1. So wherever we see the x again, plug in a plus 1. This time we square it, minus a plus 1 plus 3. And then here, the only tricky part is to know that you have to square it first. A plus 1 to the second power really means a plus 1 times a plus 1, right? Don't fall into that trap of sometimes students tend to distribute that 2 of an exponent to the other exponents, which is incorrect. So it becomes a binomial times a binomial. So you've learned to FOIL, first, outer, inner, last. So you get 2 times, and I'm just going to go ahead and do the FOIL, but you can do the FOIL on your own on some scrap paper. But you should end up with the result of a squared plus 2a plus 1, right, minus the a plus 1 plus 3. And then, of course, we distribute. We get 2a squared plus 4a plus 2, and then distribute that. That's like a -1 right there, or it just changes everything in the parentheses to their opposite, minus a minus 1 plus 3. And then lastly, we would just want to combine like terms. So we have 2a squared. I see a like term of 4a and -1a, so that's 3a, and all constants are like terms. So 2 and -1 is 2, plus 3 is 5, and that would be our result. Sometimes they may have something that looks like this, 2 times f of a. Well, again, we're using that same original function, right, 2x squared minus x plus 3, but we've already done the f of a. We've already done that. When we did f of a earlier, you can rewind back, we got 2a squared minus a plus 3. So all this is saying is to multiply that 2, that constant of 2 times that f of a. So we get 4a squared minus 2a plus 6. Okay, so that's another way you may see them ask you further problems on it. Sometimes they may write, let's see, let's find f of, let's do 2a. Okay, so again, the original, you should have this as 2x squared minus x plus 3. So this time they're saying, okay, let's just substitute 2a in for x. So f of 2a is equal to 2 times 2a squared minus 2a plus 3. So here you just have to go ahead and use the exponents first. So that'll be 2 times 2a squared is 4a squared minus 2a plus 3. And now distribute the 2 times the 4a squared. That'll be 8a squared minus 2a plus 3. All right, and that's what we have there. And maybe another one that they could ask would be to find f of a plus h. F of a plus h. So again, we plug that into the original function of 2x squared minus x, 2x squared minus x plus 3. So we'll plug that in, the a plus h. So we have 2 times a plus h squared minus a plus h plus 3. And here again, order of operations says to do the exponents first. So what does this mean right there? This a plus h squared means a plus h times a plus h. You have to FOIL that. So you should get a squared plus 2ah plus h squared once you do your first outer inner last FOIL method to get this a squared plus 2ah plus h squared. I'll distribute this now, minus a minus h plus 3, and now we'll distribute the 2 times everything inside of the parentheses and get 2a squared plus 4ah plus 2h squared minus a minus h plus 3. And then I want to look and see if I can combine any like terms. 2a squared and 2h squared are not like terms. 4ah doesn't have a like term with anything. A and h are not like. So this will be the furthest we can go with that. And these are just different variations that I hope you saw of evaluating functions when they give you the input, those independent variables. All right, thanks. Have a great day.